Hello students, welcome to Sri Jayendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 10 of a unit electrostatic potential and capacitance. So let's begin with today's class. Basically what we know is this unit has been divided in two segments. First segment is the electrostatic potential and the second segment is of capacitance. So we have done with the potential, we have done everything about the potential, and today we are going to start with the capacitors and capacitance. So let's begin with the today's class. First thing, what is capacitor or why we require it? So we can say that a capacitor is a device which is used for storing the charges. So we are going to use the capacitor to store the charges. It generally it contains two electrical conductors, generally what we say is a plates, and that has been separated by a certain distance, and that separation between two plates, separation between a two plates will be filled by a dielectric. If there is nothing, then we say that air has been filled as a dielectric, and even we have placed a certain dielectric materials within the plates of the conductor. And why we use that? Because we can increase the capacity of capacitor. How? We will see in the next classes. But for us, what a capacitor is, it is a device which is used to store the charge. And general architecture or general structure of the capacitor will be, it will be having a two plates or two conductors, and there must be a finite distance between these two conductors, then we can say that this is a capacitor. Okay, one question that arise in your mind is that if we are going to use the capacitor to store the charge, yes, then why the battery is used? I hope you understand this. Battery, or rather you can say it's a cell. Yes, that even cell were there, even a cell was there which is used to store the charge. So why to use a capacitor? Let's have an answer in next slides. So what we can say is the electrical capacity or capacity of a conductor is, it is the ability of a conductor to store an electric charge, or rather we can say by storing a charge means we are saying about the storing of energy. What we can say is that charge on the plates of a capacitor is directly proportional to the potential difference at the two ends of a capacitor. That means Q is directly proportional to the potential difference applied across it. And if I remove the proportionality symbol, I can add one constant. Please remember this. If I want to remove the proportionality symbol, I can add one constant. This is a constant, and that is what we introduce as a C. So this is how Q is equals to CV, and this C is known as the capacitance. So capacitance can be termed as in Q by V. Yes, it is the ratio of the change in an electric charge in a system corresponding to the change in the electrical potential. Please understand that Q was directly proportional to the V, and to remove this proportionality symbol we are introducing one of the constant. So on a equation point of view, it can be seen like this: C is equals to Q by V. But it doesn't mean that if V is constant, then if I increase the Q, C will increase. No, this is absolutely false. Because C is a constant. If you are going to change the V, then Q will change. If you are going to change the Q, then V will change. But the C remains the same because it is a constant. Yes, there are certain ways through which you can change the C capacitance, but there are no absolute ways that if you are going to change the Q, C will be changing, or if you are going to change the V will be changing. If Q is changing, it will change the V, or vice versa of the same is true. If the V is changing, that means charge would be a change, not a C one. I hope this is clear and you will remember this. Yes. So so its unit, it's a farad or 1 coulomb per volt. Yes, dimensional formula you can easily derive the C is equals to Q by V. Then Q, you can write it as an I into T, and voltage, it's a work done by charge, so this is I square T square divided by work done. And from this you can derive this, it's an M minus 1 L minus 2 T to the power 4 A to the power 2. One more thing, capacitance is always a positive quantity. It is the ability to store the charge, which could not be a negative. So it is always a positive quantity. And these are the symbols of the capacitor. This is the fixed capacitors, and this is how variable capacitors. This arrow shows that it can change it. And by change it, we can say it's a variable capacitor. Yes. So uh, very first slide we were discussing about that if it is used to store the charge, then why battery is not to be used. Here is the answer why we use a capacitor. It is the purpose of capacitor. It is used to store the electric charge statistically and temporarily. Here the answer is, while storing charge, it also stores electrical energy when we require. When we require that I want to store a charge temporarily and statistically, I can use a capacitor at that place. When we are talking about the battery or we are talking about the cell or battery stores the charge permanently. If you remember that if you go to the market and purchase one of the pencil cell, yes, that we call as a pencil cell, generally of 9 volt, yes, so that stores a charge permanently. But when you require a certain amount of charge spontaneously but temporarily for a fractions of second only, you can use a capacitor. Yes, it can safely absorb large amount of charge and similarly release that large amount of charge. That is why we require to release large amount of charge on that fractions of seconds. Yes, so please remember we are using this to store the charge temporarily. Next, where do we use this? Use of capacitor. Where do we use this? That every electrical appliances, you can say a radio sets or a television sets, computers, other electronics instruments, even you will see them on the tube lights, even on the fence. Yes, if you want to see the capacitor, then ceiling fan would be there. In a ceiling fan, if you see on the top of the side, there are two cylindrical components would be there, something like this. Yes, something like this. These are the capacitors in the fan. So these are the capacitors. Yes, we generally see them at every electrical appliances. Capacitor is to be used because when we just want to switch on the device, we need to provide a certain amount of energy, and that amount of energy should be provided to the device in fractions of second, so that it can starts working momentarily and steadily and very rapidly. That's why we use the capacitor. I hope this is clear. Yes. Now different types of capacitor depending upon the shape of the conductor. There are majorly they are the parallel plate capacitors, spherical capacitors, cylindrical capacitors, etc. When we add the dielectric medium, there are electrolytic, paper, mica, and ceramic capacitors. Depend on the dielectric medium we are going to use. Yes. So now let's look one by one all those capacitors which are being used and which are to be formulated. So let's begin with the very famous and mostly used. It's a parallel plate capacitor. We call this as a PPC. It's a PPC, parallel plate capacitor. What we have done here is that this is my first plate, and let's suppose that this plate has been given a charge plus Q. You can see over here that surface charge density has been mentioned. This is plus sigma, and if plus charges has been given on one of the plate, on the other plate it's a minus of Q, so negative charge may be deposited over here. This is due to induction of the charges. So One of the plate is there which is having plus charge, another plate is there which is having a negative charge. The separation between these two plates, the separation between these two plates is the d. Their cross sectional area, the cross sectional area between two plates, or the cross sectional area of each of the plate is a. Now I want to find out, the capacitance of a parallel plate capacitor. When you need to find out, when you need to find out the capacitance of a parallel plate capacitor, always the approach would be the same. Let's have a look what it would be. First you need to find, you must be clear that C should be is equals to Q by V. So every time you should focus on voltage or the potential difference of the construction, and once you are done with the potential, just divide that term, divide the charge with that term, and when I can do a Q by V, it would be a capacitance for me. I hope the things are clear to you. So let's begin with this parallel. For the parallel plate capacitors, we are just searching out that what the potential would be. And for potential, can we have uh, any other alternate to find out the potential? We have two approach. One of the approach was E is equals to minus of dv by dx, and from this we can calculate it's an integration of minus of E dot dx. This is first approach. And the second approach is if my voltage is constant or my electric field is constant and it is not, there is no any variable terms, then I can have this V is equals to E into D. These are the two approach to find out the voltage. So let's find it out. We know that electric field electric field between two plates of a capacitor, what is it? That this is plus, this is minus. Due to this, if I consider electric field at this point, due to this positively charged, this is plus sigma, and if you observe, then this is minus sigma. So what I can write is due to this positive plate, the electric field will be equals to sigma by 2 epsilon naught. Electric field due to this minus of charge, remember this is the minus charge plate. For the minus charge plate, magnitude remains the same, but direction will be towards inside the plate. It would be E is equals to sigma by 2 epsilon naught. So when I find, let's name this as an E1, this as an E2. So when I write E net, that should be is equals to E1 plus E2. So this E1 plus E2, it's in sigma by 2 epsilon naught plus sigma by 2 epsilon naught, that is equals to twice of sigma by 2 epsilon naught, and this will be a sigma by epsilon naught. I hope this is clear. So we know that electric field inside the plate, electric field will be inside the plate, would be equals to sigma by epsilon naught, and we know that E is equals to V by D as well as V is equals to E by D. So V is equals to value of E, it's in sigma by epsilon naught into D. Now what is the value of sigma? That I know, sigma is equals to Q by A. It's a surface charge density. Yes. So let's put up the value of this. It's a V is equals to Q by epsilon naught A into D. So if we replace the value, if we, this is the V, if I need to find out the C is equals to Q by V. So if I put the value and get it solved, then what I can have is this: C is equals to epsilon naught into A divided by D, where A is the area of plate, and D is the separation between two plates. So A is the area of the plate and D is the separation between two plates. One more thing, to change the capacity, of a PPC, I mean parallel plate capacitor, we have a two option at this point of time. That C, parallel plate capacitor directly proportional to the cross sectional area of a plate. So if I increase the cross sectional area, I can have a more capacity. And the one more thing is the C is inversely proportional to the D. So if I increase the D, then the C will decrease. But if I decrease the D, the C will increase. Why so? I hope you might understand. If not, then let's have a look at this. That let's look. Suppose this is one of the capacitor. This is having a positive charge, and this is having a negative charge. But if I choose a capacitor something like this, then I hope you can understand that this capacitor, a second version of this capacitor, can store much larger amount of charge, as compared to the first capacitor. Yes, so this is having C is directly proportional to the cross sectional area. Next approach, as soon as area is increasing, capacitance is increasing. Let's say this is first capacitor, and the separation between this two capacitor is this much. So here the minus of charges would be there, and if this is the second capacitor, you might observe that as soon as you decrease the separation, between two plates of a capacitor, that means you may have a more amount of inducing charges, and as soon as you are having a more amount of inducing charges, you are having, or you must be having, with the more capacity. I hope this is clear. So two parameters on which, at this point on which two parameters capacitance, it depends. First, it depends on the directly proportional with the cross sectional area, and second, inversely proportional to the separation between two plates. I hope these things are clear to you. Is it is it clear? Is it clear? Are you sure with this? So let's have one of the questions of this thing. What they asked is that find out capacity of given capacitor. This D is the 2 mm, and the cross sectional area is 4 centimeter square. Yes, it has been filled with nothing. That means it must be having an air in between these two plates. What do you need to find out? You need to find out the capacity of this. So how could you have it? We know that for parallel plate capacitor, C should be is equals to epsilon naught into A by D. Epsilon naught, let it keep as it is. It's a 4 centimeter square. So if centimeter square and to be converted to a meter square, it's a 4 into 10 to the power minus of 4. divide by divide by 2 mm, it's an mm, 10 to the power minus of 3. So this is equals to 2 2s are 4. This should be twice of epsilon naught multiplied by 10 to the power minus 4 plus 3. So this is equals to 2 into epsilon naught multiplied by minus 4 plus 3. It would be a minus of 1. This would be 0.2 epsilon naught farad. This would be the final answer. Is it clear? Is it? Is it clear? Are you sure with this? Yes. Have you done with this? Did you? Great. Let's move on to the next. The question is that if separation between two plates of a capacitor is 2 mm. Its capacitance is 10 microfarad. Find its capacity if separation is 6 mm. This is what they require. Now what will you do? Yes, what they have changed, the separation only the changes, so there is no change in the cross sectional area. Yes, so what I know is that C inversely proportional to the D. C is inversely proportional to the separation between the two plates of a capacitor. So if this is the case, what I can have is it's a C2 by C1, and that should be is equals to D1 by D2. As we know that 2 is used for the new capacity and 1 is for the previous capacity. So this is C2 divided by 10 microfarad should be is equals to D1. It's an initial separation. This is 2 mm and this is 6 mm. So this is thrice of this. So C2 would be equals to 10 by 3 microfarad. This should be the answer. What was yours? Is it same? Does it? Great work. So shall we move to the next? Are you ready, guys? Let's have a look. The next is, let's say this is the first plate A1 and this is the second plate of a conductor, and this is the separation between two plates. This is the separation between two plates. Now they ask that, let's say this has been positively charged and this is negatively charged. They say find out capacity of capacitance. This is what the requirement is. Now how can you find out? How could you? What you are supposed to do? You need to find out the capacity. So when and when this kind of situation happens, you need to always look for the overlapping area. What I mean overlapping is that, let's look at this area. This area has been covered by both. So what I need to choose is that C is equals to epsilon naught multiplied by A1, because it is a cross sectional or it's an overlapping area, divided by D. Please remember this. This is very useful concept, that when and when we have two plates having different cross sectional area, which one I need to choose? I need to choose an area. Which one is the shorter one? Because the shorter one would be a mostly overlapping area. Mostly. Yes. If not, then you need to choose and you need to observe that which one is the area which is overlapping in both the plates. And only that area will form the capacitor for me. I hope this is clear. Is it? Any doubts? No? So shall we move to the next capacitor? Shall we? Let's move on. This is the capacitance of a spherical capacitor. This is the capacitance of spherical capacitor. What we have done is that we have given a charge q on the inner plate of a conductor, inner plate of the sphere, and due to this charge q, here the negative charges has been induced, that you can see it's in q induced. Even a positive charges might be there, because of this a positive charges would be there. And now I have connected this with the ground. So as I connected this with the ground, I assume that all the positive charges has been moved to the ground. All the positive charges has been moved to the ground, and as it is moving towards the ground, the situation would look like this. I hope these things are clear to you. is it? So this is q induced, which should be equals to minus of q. And now if I see the situation that this is my first plate, this is my second plate, the outer sphere has been connected with the ground, and within this two spheres there is nothing. That means there must be an air, and if there must be an air can behave as a dielectric. So what I can have is I can say that this is the construction to which I can say that this is my capacitance. I hope this is clear. So how can you calculate the capacitance of the given construction? Yes. What was the idea? The idea behind this is C should be is equals to Q by V. As this put as this is grounded. So let's write down the potential. So I have written this as a V minus of 0, because a 0, when any surface has been connected with the ground, its potential would be a 0. So this V minus 0 should be is equals to q divide by 4 pi epsilon naught a. Let's say this is a and this is b. Q divide by 4 pi epsilon naught a minus of q by 4 pi epsilon naught b, and this will give me a q by 4 pi epsilon naught as a common, multiplied by 1 by a minus of 1 by v. Yes. So if I write this, then c is equals to q divide by v. C is equals to q divide by v. What I can have is that q divide by q by 4 pi epsilon naught into bracket 1 by a minus of 1 by b. This q would be a gone. This q would be a gone. And if I write this, it's a 1 divided by 1 by 4 pi epsilon naught into bracket b minus of a divided by ab. Yes. Or I can write like this, it's a 4 pi epsilon naught upon 1 by a minus of 1 by b. I hope this is clear. Or rather you can remember this, it's a 4 pi epsilon naught ab upon b minus a. Yes. So this is 4 pi epsilon naught upon 1 divided by inner radius minus 1 divided by outer radius. Or you can simply solve this. Yes. Is it clear? So now can you find out the potential of any system? Can you? Okay. First have one of the question. Let's have one of the question of the spherical capacitor, and then we will move on. The given data is, let's say that this is one of the sphere, this is another sphere, this has been grounded. Here the plus q has been given, and as this plus q has been given, so charge has been induced over the outer surface, and it would be of minus q, that you understand. Yes. And the inner radius is 2 centimeter, and the outer radius, this outer radius is 4 centimeter. We have been asked that find out capacity of the given construction, or I should say given capacitor. So what I know is that C should be is equals to 4 pi epsilon naught into AB divided by B minus A, while B is the outer radius, A is the inner radius. So let's have a value of this. It's a 4 pi epsilon naught multiplied by A into B. It's a 2 into 4, that is 8 centimeter into centimeter. That's my, it's 10 to the power minus of 4, divide by 4 minus 2, it's a 2, but again it's a centimeter only, it's a 10 to the power minus of 2. So this is 2 4s are 8. So this is 4 into 4, it's a 16 pi epsilon naught multiplied by 10 to the power minus of 4 plus 2. So this could be 16 pi epsilon naught into, this is minus 4 plus 2, so this would be is equals to 10 to the power minus of 2 farad. This would be the final answer. I hope this is clear to you. Is it? Is it clear? Is it? Are you sure? Yes. One more very interesting aspect of this capacitor. Let's have a look. Oh, very interesting that this is the inner sphere and this is the outer sphere. The inner radius is A and the outer radius is B. Yes, and you need to connect this with the ground. Yes, this is the situation, and what we know is that here the positive charge has been provided, and due to this positive of charges, a charge has been induced on the inner surface of the second conductor, and this is minus of q. Yes, I hope this is clear. So what capacity do I have? I am having a capacity of 4 pi epsilon naught upon 1 by a minus of 1 by b. Now please listen and try to understand this. If if my second plate, or if my second sphere is at infinite distance, find out new capacitance of the system. This is what they require, that if my second sphere is at infinite, if my second sphere is at infinite, find out the new capacitance. So what I can know is that my b tends to an infinite, and as my b tends to infinite, my new capacity or my new capacitance would be equals to, this is 4 pi epsilon naught divide by 1 by a minus 1 by infinite would be a 0, so this is equals to 4 pi epsilon naught into a. This is the new capacity of my system. This is 4 pi epsilon naught a. If you wonder that where is my second, where is my second plate, it should look like something like this, that a sphere is there and the sphere has provided a charge q. Now you are finding out the capacity of this. Then you might wonder that, sir, where is the second plate? Because when we started the capacitor, you told us that a capacitor is the construction which must be having a two plates and they are separated by certain distance. Yes, so here second plate is that, but second plate is at infinite. Yes, and from this we are going to find out the capacity of this. I hope this is clear. Please always remember this. This will help. Let's look at the same thing. Let's look at the same thing by a different approach. That this is the spherical capacitor and this is the isolated conductor, or we can say isolated sphere, and I need to find out the capacity of this. I need to find out the capacity of this. What is it? What is it? Let's have a look. That a sphere has been conducted and it has been provided with the charge q, and what I need to find out, I need to find out the capacitance of this. How could I do it? It's a q divided by v, simply this. What is v? That I know it's in k q by r. Yes, now c is equals to q by v and there is 4 pi epsilon naught into r. It is the same thing that we have derived previously. If it has been placed in certain medium, then it's in 4 pi epsilon naught into epsilon naught r into r. So capacity of this spherical capacitor depends on the size and shape of the conductor, because it depends on the r, it depends on the surrounding medium, as well as it depends on the presence of the other conductance which has been placed nearby. But you must remember this. Yes, c is equals to 4 pi epsilon naught into r if it has been placed in the air. So from this concept, a very famous question is there, that the people ask, that find out capacitance of earth. While asking this, they want that assume that earth has been charged by charge q. So they assume that this is my sphere, which is basically a earth. So this is the radius of the earth, and this sphere has been provided a charge q. Where is the second plate? It is at infinite. Where is the second plate? It is at infinite. And you want that I need to find out the capacity of this structure. So what I can do is I can simply find out the C is equals to 4 pi epsilon naught multiplied by R. So if I replace the value, it's a 4 multiplied by pi multiplied by epsilon naught. It's an 8.85 into 10 to the power minus of 12 multiplied by, this is radius of the earth. What is it? Radius of the earth. Did you remember this? Do you? No, you must. It's a 6.4 into 10 to the power 6 meters. So if I solve this, if I just solve this and calculate this, it would be approximately 712 microfarad. This is to be remembered that this is the capacity. This is the capacity of earth, that if we have been provided earth with the charges, then this should be the capacity of the earth as a spherical capacitor. Yes, remember this. So shall we move to the next capacitance? Yes, shall we? So let's have a look. It is the cylindrical capacitor. As you can see in the diagram, that charge plus q has been provided to the inner cylinder, and as it is a positively charged, on the outer side it is a negatively charged. It's a charge, induced charge would be there. And on the outer surface of the conductor, of the second conductor, there must be an positively charge would be induced over here. Yes, but as I have connected the outer sphere with the ground, as I have connected outer sphere with the ground, I assume that that conductor, that charges has been gone through the ground. So my situation and my construction should look like this. I hope this is clear. Yes. So two cylinders are there. Presently it has not been filled with anything, so there must be an air within this. And the cylinder, or the outer cylinder, has been grounded. So I have basically two plates. They have a charges of plus and minus. And what I need is, I need the simply the capacity of this construction. So how could I do this? The steps remains the same. What I require C. How could I do this? I can do with the help of Q by V. So first task would be to find out the V. How could I find out the V? It is the same thing. E is equals to minus of dV by dr, and from this V is equals to minus of E dr. So let's look at this. What I know is electric field between cylinder E. I need to find out the electric field between cylinders. If you remember this, we can have this. It's a 2k lambda by r. So basically it is a lambda divided by 2 pi epsilon naught r. Now what is lambda? It's a linear charge density. How could I calculate it? Let's say this is the length of the cylinder. It's a q by l divided by 2 pi epsilon naught r. So let's find it out the potential. Let's find it out the potential difference between plates. So if I find out the V, that means I'm going to integrate this from inner radius is R1 to the outer radius is R2. From R1 to R2, it's a Q divided by 2 pi epsilon naught R into L. Whatever the terms that are constant, that has been put on this side, it's a Q by 2 pi epsilon naught L. And then I integrate dr by r. Integration of dr by r, it's an ln r. Put up the limits. it's a ln r2 by r1. So this is the potential difference between the two plates. This is V. Now the term remains, it's a C. It's a C is equals to Q by V. So if I divide the Q with this potential difference, what I can have is it's a 2 pi epsilon naught L divided by ln of E R2 by R1. Yes, I hope those things are clear. Is it? And if this capacitance has been put up in certain medium, then I need to simply multiply this with the relative permittivity of that medium. I hope these things are clear to you. Is it? Is it clear? Yes? Any doubts? Any doubts so far? No? So let's wind up here. In this class, we have been discussing that what is potential, why we use this, and where we use this, and we have derived also the relations for the three capacitance. It's a spherical capacitor, parallel plate capacitor, and cylindrical capacitor. You must remember the formula of this one. Yes, so try to solve as many questions as possible. We have already done with the potential, so always revise that potential part, because if we are not going to revise the same, we are going to skip or we are going to forget certain topics and certain concepts of the potential, and it will make a huge harm to us. So please revise it, please revise it. When we meet on the next time, we are going to move with the new topics and more advanced topics to the capacitor. Till then, bye bye, have a good day, take care.